Hi, my name is Andrew Turner, and I teach Algebra 1 at Central High School, and I'm going to be doing a series of videos for the KCS at Home Summer Edition, and this very first one is about quadratic functions. So if you have any questions, please shoot me an email at andrew.turner@knoxschools.org, and I'll be happy to answer any of your questions about the materials or the video. So the very first topic that we're going to be talking about is the features of a quadratic function. You may be asking, well, what is a quadratic? A quadratic is when you have a variable or a value that is being squared. And so, for example, if you have x squared plus 3x minus 4 in red, we can plug in different values for the input-output to create different points on this graph. For example, I could plug in 0 squared plus 3 times 0 minus 4. That would give me -4 as an output. And I can see several other places on the graph that are very important. But let's start with that very first one, the y-intercept. The y-intercept is an important value on the graph, and this is where the x value or the input value is 0. And it can be found in the back of the equation form right here. This value can always tell you the y-intercept when you're looking at the equation. Now, the form above it, this is called factored form, and factored form reveals other information. It reveals more information about the x-intercepts, or what we call the roots, or the solutions, or zeros. These all really mean the same thing, and they're all referring to the places on the graph where the output value is 0. So in this case, we wanted the x to be 0, or the input to be 0, but in both of these points, the y value, or the output, is 0. And so we're looking for that x value, and it can be found with factoring. And so we can also find an important point down here, because all quadratics take on this U-shaped curve, and it could be facing up, it could be reflected and facing down, but really one of the main important places on the graph is the point where it turns around. Maybe it turns around at a bottom point, which we call a minimum, or maybe it reaches a maximum point at the very top before it turns back around. But that point is very important because we call that the vertex, or the minimum for this one, because it is at the bottom. And then the last little vocabulary we want to talk about is the word symmetry, for the idea of axis of symmetry. There's this invisible line that can cut the graph in half, because all U-shaped quadratic graphs have this symmetry that can cut the graph right in half. And so there's this invisible line that would cut right through that vertex point, and that's called the axis of symmetry. And so we're going to learn a little formula for the axis of symmetry, -b/2a, and that will help you find where that center vertex value is and where that axis of symmetry lies. And so let's talk a little bit more about that. When you're talking about standard form, when you're given a quadratic that's given where each of the values seem to kind of step down in power, you have a power of 2, you have a power of 1, and then this last constant doesn't have a variable on it at all. And so we have what's called the general standard form of any quadratic, and those letters A, B, and C just represent possible values in the problem. For example, for this problem, we have A, which is the value 1, B, which is the value -4, and then we have C, which is the value +3. And we can use these values with our calculator, with our formulas, with different graphing technology to tell the calculator or tell the technology what kind of equation we're looking at, and it would create different graphs or do different regressions or whatever you're doing at the time. And so we're going to talk about finding the axis of symmetry using that formula I just mentioned, -b/2a. So what you can kind of look through in my guided notes here is that b was -4, and in the formula it's already got a negative in it, so it's like -4, and then you're dividing by 2 times the a value, and for this one is a 1. And so when you calculate negative 4, that really comes out to be positive 4. And you're dividing 2 times 1, which is 2. And so that's why we're going to say that the vertex has to start when the x value is 2. And so we kind of have that graph here. And we can see right here where the x value is 2, we're going to have some symmetry. There's this invisible line that could kind of cut that graph in half. That's called the axis of symmetry line, x equals 2. And then if we wanted to know the other value of that ordered pair where that vertex lies, we need to take time to plug 2 in. So let's say that we've figured out that we know 2 is the input value for the vertex. We can plug in 2 and do all of the math from the equation. So 2 squared would be 4, and negative 4 times 2 would be negative 8. And if you add 3 to all of that, negative 4 minus 8, or sorry, 4 minus 8 is negative 4, plus 3 is negative 1, and that is the y value that we're getting in the picture, or for our graph. And so we may want to plug in other values around it. We may want to plug in 3, or we may want to plug in 1. And so when we use the input value of 3, we actually end up getting 0, and that's one of our root points. Other words, x-intercept, solutions, and when we plug in 1, we'll also get out 0. And so that's another one of our x-intercept or root points. And so we also want to notice that if you were to plug in 0, for the x value or for the input value, you will always just end up with that constant in the back, because when you replace x as 0, basically it's just getting rid of all of the other parts of the equation, and that's quickly telling us our y-intercept. So all graphing is based on an input-output process. You plug in different values of x, you get out a different output for y, and then that creates a point on the graph. But there are a lot of symmetry ideas that you learn along the way. For example, once you know that you had your vertex point here, there's some up 1 over 1 symmetry to get you to the next point. And we'll learn in calculus and other classes certain processes that you can kind of go through to find the next point rather easily. So be on the lookout for those patterns if you see them. So it says the graph represents the function negative 2x squared plus 8x. We want to identify a few different ideas, vocabulary that's based on this graph. So let's do a few example ideas together. So the first thing we want to talk about is domain and range. Domain and range is a pretty complicated concept, but basically domain has to do with any possible x values that are found on the graph, and range is any possible y values that you find on the graph. So we're basically studying what is possible for the input and the output. Well, when you're thinking about input, I can plug in for x any value I want. I can plug in a positive number, I can plug in a negative number, I can plug in a decimal, and you can see that basically I'm getting points pretty much everywhere there's an x value to be plugged in. And you may ask yourself, well, what about 5 or 6 or 7? The graph doesn't seem to go that far. Well, it will. And there's this arrow here that suggests continuity. It's going to keep going. And so, yes, there will be a point that corresponds with 7. When you plug in 7 for x, it will give you some value, but it'll be way down in the negatives. And so all that to basically say that the possible x values for input are any value, and so we call that all real numbers. Meaning, you can replace x for any value you want. You can make it 0, you can make it a square root value. The input is not restricted. But for the range, we notice that it goes down forever. We're getting the output values all the way down towards negative infinity, but it seems to kind of top out at a point that seems to be 8. And so it never goes above 8, like 10, 12, 14. Those aren't possible output values. So I may say, well, all the y values are less than or equal to 8. And that's called inequality notation, describing for that variable y, or for the output, that all its values are 8 or less. And so now I want to talk about the y-intercept, which I'm looking for. Again, that is when the input value is 0. And we can see that this one actually hits the origin. And so I want to plug in 0. And to bring back an idea that we mentioned a few minutes ago, ax squared plus bx plus c, for the general form of this quadratic, you have an a, -2, b, you have an 8, but the c, that constant, you're missing, so it's like a +0 in the back, and that's also corresponding to your y-intercept value as well. So be on the lookout for that c value. That's the y-intercept. So then it asks for the x-intercepts, or the zeros. The x-intercepts are where they cross the x-axis, and one of them is the same, 0, 0. It hits the x-axis at 0, 0. It also hits it at 4, 0. So those are the 2 points where it hits the x-axis. Those are called the 0 points. And so now I'm looking for the axis of symmetry, and axis of symmetry is a vertical line that would cut the graph in half, and it seems like it would go right through it when x is 2. And that actually reveals the vertex point for me, because now I can see the vertex is that point where it turns around to 8. And because it's at the very top of the quadratic, I think I may just go ahead and make a note that that's a maximum point. And now it's asking for the interval of increase and decrease. So you may think of it as on the left side, it's going up to the top of the point, and then on the right side, it's falling and going, falling down and going decreasing from that point. And so basically, it's all about what side you are on of 2. So it looks like on the left side, whenever the x value is less than or equal to 2, you're on the increasing side of the quadratics, going up, 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 up. But once you cross when x is 2, the quadratic seems to fall, and as you move, the increasing values of x decreases the output. And so I want to say, well, that's when x is greater than or equal to 2, that you're on a decreasing part of the graph. So we'll take the last few minutes of the video to talk a little bit about vertex form. Vertex form takes on a slightly different style of writing compared to standard form. Standard form, you have your A and your B and your C values, but when you're looking at vertex form, it's more about identifying what we call H and K. And K is a fairly safe value to look for, but this other value, this H, it's a little more dangerous because you have a minus in the formula. And so, for example, this x minus 2 squared minus 1, that's really going to turn around at the point 2, -1. So we really want to watch out for that h value. So I want to do just some quick examples. This first one, x minus 5 squared minus 3, the vertex would be at 5, -3. And that means that the axis of symmetry would have to cut through that vertex point at x equals 5. So 1, 2, 3, 4, 5, 1, 2, 3. So that's my 5, -3, that's my vertex. And then I have an axis of symmetry that I can create my u points. And I've done it a lot, so I kind of know some of the patterns between these points that makes it a little quicker to graph. But you can use a graphing calculator, or you can use input, output, plug in 1, plug in 2, find different points in that coordinate plane. So for example, this one turns around at -1, 4, and it has an axis symmetry right through x equals -1. So I'm just checking my time there. So -1, 4. And so this one, because I have that negative value out front of the parenthesis, it's actually going to force the graph to reflect down forever. So it's still a U-shaped graph, but it's kind of facing in the opposite direction. So we'll practice a little bit more of the forms, and in the next few videos we'll talk about solving quadratics. See you then.